There's a great variety of different topics that come up within forensic science. It really is a subject of great diversity, as can be seen from this slide. And while we're looking at all this diversity, we should try and dispel a myth that is built up by watching CSI shows on TV. And that is that an individual forensic scientist would never be able to tackle all the subjects that you see in front of him. It really is a subject for specialists. People specialize in one area of forensic science, and they do not work as generalists. In particular, we can split forensics into two areas. On the left, you can see forensic medicine. And forensic medicine is very clearly defined because it's purely concerned with a body, whether it's a living body or a dead body. Looking at that body, working out how injuries may have happened to that body is the job of specialists in forensic medicine. And anyone in the field of forensic medicine will have got there by first qualifying as a medical doctor and then specializing further. On the right, you have what is properly called forensic science. And this is dealing with just about everything that is not a body, from fingerprints through to DNA. And people in this area tend to have a good qualification in one of the basic sciences. So you have forensic medicine on the left, forensic science on the right. Now, television programs have made forensic science very fashionable at the moment. But even without TV, many forensic scientists have achieved some kind of celebrity status. On the left is Singapore's own Chao Zi-Cheng. His area, of course, was forensic medicine, and he was one of the founders of this area here in Singapore. In the center, you see Dr. Pontip, and she's one of the most well-known practitioners of forensic medicine from the Kingdom of Thailand. And on the right-hand side is one of the first celebrities of forensic science or forensic medicine, and this is Sir Bernard Spilsbury. And during this course, we'll discuss a number of the cases that came in front of Sir Bernard. And he was a great authority figure in forensic medicine in Britain, certainly in the first few decades of the 20th century. When you spend a long time studying forensic science and looking at the different crimes that have been committed, you may start to get worried about going home or going outside your house. So to begin the course, I'd like to offer you a little bit of reassurance that the world, or at least most of the world, is actually a fairly safe place. So here I've selected some murder rates for different places around the world. So if we exclude countries where there is actually a war going on, then the highest murder rates are in countries such as Colombia. A few years ago, the rate in Colombia was much higher. It dropped in the last few years. It's still a very high rate by worldwide standards, and this is due to drug gangs. And it's particularly concentrated in a few cities, such as Medellin, where the drug gangs have been very powerful. Currently, one of the highest murder rates in the world is Honduras, and again, that is due to drug gangs. And the murder rate there recently was reported to be 71 per 100,000 of population per year. From watching TV, because so many crime shows on TV comes from the United States, we often think of the United States as a very violent country. But their murder rate is only 4.7, well below that of Honduras and Colombia. The interesting thing about the United States is the great variety within one country. So that 4.7 average hides huge areas where the murder rate is almost zero, and a few places where the murder rate is much higher. For instance, Washington, D.C., the murder rate is significantly higher, almost up at Columbia levels. Actually, that murder rate for Washington, D.C. is a great improvement over a few years ago. Here in Singapore, it's relatively low at 0.51. Here in the United Kingdom, where I come from, it's 1.23. And other countries in Europe, for instance, it's that order of magnitude. So don't be afraid to step outside your house. Generally, it's not that dangerous a world. Now, in this course, what is it we're trying to explain to you? What is it that we want you to take away from this course? It's basically summed up by this question: how did they know? When you hear forensic scientists or prosecutors or police officers saying they have very strong evidence that this act was done by this person at this time in this way, you should wonder to yourself, how do they know? And usually how they know is based upon forensic science. So this course is about explaining to you some of the scientific principles that lets them make these statements. It's about the interpretation of the evidence. The evidence is found at the crime scene. The evidence itself is merely physical objects or physical measurements. These have to be interpreted. So it's how this evidence is interpreted by the forensic scientists. But a very important part is not just the interpretation of the evidence, it's understanding how that evidence can be trusted and to what extent it can be trusted. How reliable is the evidence? When DNA evidence is presented in court, it's presented with great reliability as if it's infallible. And in general, DNA evidence has tremendous reliability because of the scientific principles on which it's based. Other forms of forensic evidence, well, frankly, some of them are definitely a bit iffy, and their reliability is low, much lower than DNA evidence. And in addition to this, we have to be aware of what we can deduce from the evidence and what we cannot deduce. As we'll see, forensic science is tremendously good at telling us certain pieces of information which go into solving a crime. But there are some aspects of a crime which are beyond the power of forensic science. So we have to know our limits. Now, what about science? Why do we consider this forensic science? And we call it forensic science because it uses the philosophy of all of science. The model of science that we more or less use these days is based on that given to us by Isaac Newton. And in the Newton idea of science, you have observations maybe of the natural world, or observations of your crime scene, or you do experiments and you have results from those experiments. And you use those observations and experiments to come up with a theory that gives you an explanation. You then go back to make further observations or further experiments which then test your theory. If those further observations and experiments support your theory, great, then you can go on for further experiments. If those observations and experiments contradict your theory, well, you've got to go back to the drawing board and come up with a new theory. And you would continue around this cycle of observation or experiment and theory until you conclude that your theory is pretty much firmly demonstrated and you have full confidence in it. Now, for most scientists, once you reach that point, what you do is you write a scientific paper or you give a presentation at a conference, and there's the end to the process. For forensic scientists, the end to the process is somewhat different, because once you are confident in your theory that explains your observations, you then have to present that theory in court. You have to be an expert witness in court and convince the judge and or the jury of the validity of your thesis. And this means that if there is a mistake in your theory, if your theory is invalid, if it's wrong, the consequences can be very serious indeed. Because if your theory is wrong, you may be sending an innocent person to prison, or if it's a country where there is capital punishment, you may be sending an innocent person to their death. And it is certainly true that this has happened and this can happen. Let us say a little bit at this point about the legal system, in particular the legal system in countries where they use a system based on the English system. So the evidence that is presented in the court when someone has been charged with a crime comes from experts such as forensic scientists. It may come from witnesses, it may come from the police officers. This is presented in the court. Some of it is presented by the prosecution, who are seeking to get the person convicted, and some of it will be presented by the defense, who are seeking the opposite. And the prosecution and the defense will maybe challenge each other's evidence, and each trying to achieve their objective. Now, the court is presided over by a judge. Now, in many countries that base their legal system on England, the decision of whether the person is guilty or not guilty is taken by the jury. And the jury is essentially a committee formed usually somewhat at random from local citizens. And the history of the jury system goes back many, many centuries indeed. The jury system is still used in the United Kingdom, in Australia, in New Zealand, and in the United States of America. And in many of these places, it's regarded as an absolute cornerstone of the legal system. In other countries, including Singapore, the jury system has been abolished. In those countries, then the decision of guilty or not guilty will be taken by a judge or a panel of judges. But the fundamental system is the same. The prosecution and the defense each try to make their case based on the evidence in the court. Another inheritance from English law is the presumption of innocence. If you are charged with a crime, if you are accused of a crime, the legal system must assume you are innocent until you are proven guilty. Essentially, there is a default setting, and the default setting is innocent. This means that it is the job of the prosecution to prove guilt. The defense does not have to prove innocence. They simply have to essentially pick holes in the prosecution's case so that they cannot prove guilt. Now, any case presented by the prosecution, you can raise any kind of doubt about their case. But the law does not allow any kind of doubt. It has the concept of reasonable doubt. If the defense can raise reasonable doubts about what the prosecution is saying, then the accused must be found not guilty. This case is a very good example of this idea of reasonable doubt. Felicia Lee had a boyfriend called Randone, and they were living together. On September the 11th, 2009, Randone made a 911 call to the emergency services, asking them to come to the house because Felicia Lee was dead. Okay, they arrived, she was dead, her body was taken away, of course, for autopsy examination. When her body was examined, they found in excess of 300 what are called blunt force trauma wounds. Essentially, she had been kicked or beaten very, very savagely in the opinion of the medical examiners. And this is why Randone was charged not just with her murder, but they also added on the very unusual and very rare charge of torture. She'd been tortured to death. So the prosecution's case was quite simple. Here's Lee in the house. The only other person there is Randone. He'd kicked her to cause these excess of 300 traumas and then had killed her by smothering. And it looks, at first glance, a pretty cut and dried case. But when a body is taken away for autopsy, the pathologist, the medical practitioner, will not only examine the body for the things that the police, the investigators, think caused the death, they will go through a whole series of standard tests because they want to check whether it may be other possibilities. And one of these standard tests that's done is blood chemistry. A blood sample is sent away for analysis. And Felicia Lee's blood was found to contain a chemical called gamma hydroxybutyrate, GHB, which is a drug. And the defense used this fact to provide reasonable doubt to undermine the prosecution's case. They called in an expert witness, an expert who had studied the effects of the drug GHB extensively. And he testified in court that these 300 bruises on her body could have been caused by her having a seizure induced by this drug. And her death could also have been caused by the fact that she has an overdose of this drug in her system. Result, he was found not guilty. Let's look at that result. Did the defense prove that her death was caused by an overdose of the drug GHB? No, they didn't prove it. The point is they don't need to prove it. All they need to do is to suggest that it is a possibility and show to the jury that it is a reasonable possibility. That is what they succeeded in doing. That is all they needed to do, and Randone was found not guilty.